If you're studying for the AWS Cloud Practitioner exam, you know the virtual private cloud, or VPC, can feel, well, like a beast. But don't worry, we're going to break it all down, piece by piece, using a simple blueprint that's going to make it all click, I promise. Okay, let's start right here. This quote is the perfect way to think about it. For a minute, just forget all the technical jargon and picture this. AWS gives you this huge chunk of their cloud infrastructure, and a VPC is basically you putting up a virtual fence around your own private, secure section. It's your land, you control everything, who comes in, who goes out, and what happens inside. So here's our game plan for today. We're going to build this thing from the ground up. First, we'll lay the foundation, our cloud blueprint, then we'll define its boundaries with something called CIDR. After that, we'll create different rooms, public and private ones. We'll add some doors to the internet, put up signs to direct traffic, and then we'll finish with a final checklist so you are totally ready for exam day. All right, let's get into section 1, your private cloud blueprint. This is the absolute foundation of everything we're about to build. So here's the official AWS definition. The two phrases you really need to burn into your brain for the exam are logically isolated and virtual network. Logically isolated just means that even though your stuff might be on the same physical server as someone else's in an AWS data center, at a network level, it's like they're on different planets. It's your own private bubble, completely walled off from everyone else. Now, to make all this stuff really stick, we're going to use a simple office building analogy. Just picture this. The VPC is the entire building. The departments or floors, like HR and development, those are your subnets. The main entrance where visitors come in, that's your internet gateway. And the security guards at every single door, those are your security groups and network ACLs. Keep this picture in your head, because we're going to keep coming back to it. Okay, on to section 2. We've got our building, but now we need to define the property lines. How big is our plot of land in the cloud? That's where CIDR comes in. I know this looks a little intimidating, right? But CIDR is just a fancy way of writing down the address range for your network. Think of it like the street address and the total lot size for your virtual property. It just tells AWS how many private IP addresses you have to work with inside your VPC. And here it is, the crucial, kind of backwards rule you have to remember for the exam. The bigger the number after the slash, the smaller the network. So a /24 network has way fewer addresses than a /16 network. It feels weird, I know, but just remember that little phrase, bigger slash, smaller space. You'll thank me later. And just a few pro tips to keep in mind. First, always use those standard private IP address ranges. Second, don't be shy. Choose a size that's big enough for you to grow into later on. And finally, and this is a big one, make sure your VPC's address range doesn't overlap with any of your other networks, like your on-premise data center. That's a recipe for major connection headaches. Let's move on to section 3. So we have our building and we've marked out our property lines. Now it's time to actually draw the floor plan inside by creating public and private subnets. So what's a subnet? It's just a smaller piece of your VPC's total IP address range. Think of it as a specific department within your office building. But here's the key exam concept. Each subnet lives entirely within one single availability zone. This is how you build for high availability, by spreading your application across subnets in different AZs. Now, there are two main flavors of subnets. The public subnet is like your office lobby. It's accessible from the outside world, so it's the perfect place for things like your web servers. The private subnet, on the other hand, is like a secure, windowless office in the back. No direct access from the outside. This is where you put the important stuff like your databases and your application servers to keep them safe. All right, time for section 4, gateways. We have our rooms, right? We have our secure offices and our lobby. But what good are they without doors? We need a way for them to talk to the outside world. This is a classic exam question, so listen up. An internet gateway is the main entrance to your building. It's a big revolving door that allows traffic to go both ways, in and out. A NAT gateway, though, is more like a secure mailroom for those private offices. It lets your internal servers send things out, like downloading software updates, but it absolutely does not let anyone from the outside initiate a connection in. Outbound only. Okay, section 5, route tables. We've got our rooms, we've got our doors. Now we need the hallways and the signs that tell all the network traffic where it's supposed to go. It's really simple. Every single subnet you create must be connected to a route table. And a route table is nothing more than a set of rules. It's the digital roadmap for your VPC that says, hey, if traffic wants to go to this destination, send it through that door. Okay, everyone, lean in for this one, because this is probably the single most important concept about subnets for the exam. A subnet is not public just because you name it that way. It's only truly public if its route table has this exact rule, a route for 0.0.0.0/0, which basically means anywhere on the internet, that points directly to your internet gateway. You will absolutely see this on the exam. And look, this diagram brings it all home. You can see the whole blueprint in action. The VPC is the big box. Inside, you see the public subnets with a route table pointing to the internet gateway. And you see the private subnets whose route tables point to the NAT gateway, giving them that secure one-way access to the internet. It all fits together. And finally, Section 6, the exam-ready checklist. Let's run through the most critical concepts one last time to make sure you're ready to ace this section of the test. You are very likely to get a troubleshooting question. So if they say your EC2 instance in a public subnet can't reach the internet, you check these 3 things, in this order. First, did you actually attach the internet gateway to the VPC? Second, does the subnet's route table have that magic 0.0.0.0 route pointing to the gateway? And third, did you remember to give the instance itself a public IP address? You need all 3 of those for it to work. Here's another absolute classic. Security groups are like a firewall for the instance itself. They're stateful, which means if you allow traffic in, the return traffic is automatically allowed out. Network ACLs, on the other hand, are a firewall for the whole subnet. They're stateless, which means you have to create rules for both directions, inbound and outbound. Think of it this way. The NACL is the big fence around the property, and the security group is the bouncer at the door of each individual office. So just remember this traffic hierarchy. For data to get to your instance, it has to get past the network ACL and the route table first. The security group only gets a look at traffic that's already been allowed through those other layers. And watch out for these common traps, creating an internet gateway but forgetting to attach it to your VPC, and accidentally changing the route table for your private subnet when you meant to edit the public one. And that's our blueprint for VPC basics. Look, building the network is the first essential step. It's the foundation for literally everything else you're going to do in the cloud. So the real question isn't just how you build it, but now that you can, what will you secure within it?